Hi all, welcome to mathematics class. This is Dr. K. Rajalakshmi working as lecturer in TSWRDC Warangal East. Today we are going to discuss about Cauchy's sequences. All you know about a sequence. What is a sequence? Sequence is a function defined from natural number set to real number set. We know about sequence. Now what is a Cauchy's sequence? Today we will discuss about that. So before going to the definition of Cauchy's sequence, first of all I would like to explain one situation. A traveler is traveling from a fixed point to O with one condition. What is that condition? After traveling of each hour, he will reduce his speed to half. That is, let us suppose he is traveling with x kilometers per hour in first hour, then he will reduce his speed to half, means x by 2 kilometers per hour. Means at the end of second hour, his speed is x by 2 kilometers per hour. Next, from second hour to third hour, his speed is half of x by 2 kilometers per hour, means that is x by 4 kilometers per hour. At the end of fourth hour, his speed is x by 8 kilometers per hour, and so on so forth. Let us suppose this is nth hour, this is n plus 1th hour. Traveler is keep on moving with this condition, but observe that the distance travelled by the traveler from nth hour to n plus 1th hour, the distance will be very small value or it is a negligible value. Means here I would like to compare this situation with the sequence. Let us take this point as x1, this point as x2, this point as x3, this point as x4, this point as x5 and so on. So consider a sequence with this point. So sequence x1, x2, x3, so on, xn, xn plus 1 and so on. This sequence is called a Cauchy's sequence. Means Cauchy's sequence is a sequence whose terms are arbitrarily close to each other as it progresses. Here we can observe the distance travelled by the traveller between nth hour and n plus 1th hour is a negligible value. He travels, but the distance travelled by the traveller is a very negligible value. Means these points are coming closer to each other. Here it is important that all the elements of the sequence after some fixed point come closer to each other. This collection of the points forms a Cauchy's sequence. Okay. Now here I would like to give one more example. Here consider a wave . Observe that here this wave is moving in this direction. After some fixed point, these waves are coming closer to each other. These waves are coming closer to each other. Means this wave following the Cauchy's sequence. Now we will discuss the analytical definition of a Cauchy's sequence. Now the analytical definition of a Cauchy's sequence. See, a sequence Sn is said to be a Cauchy's sequence if for any epsilon greater than 0, however small, there exists a positive integer n, there exists a positive integer m such that modulus of an minus am less than epsilon for all n greater than or equal to m. This is the definition. Any sequence is said to be a Cauchy's sequence if for any epsilon greater than 0 there exists a positive integer. Actually here this positive integer is depends on the value of epsilon such that modulus of an minus am is less than epsilon for all n greater than or equal to m. Here you can observe that all these terms are coming closer to each other because distance between them is very small value or it is a negligible value. We can also write this definition as, that is also same as modulus of, see here, n is greater than or equal to m, means n is equal to m plus something. So I am writing this n as m plus p minus am less than epsilon. What is this something? I am considering that as p. P value is greater than 0. As m and n are positive integer, p is also a positive integer, so it belongs to n. So this is the analytical definition of a Cauchy's sequence. Now consider an example. Suppose one sequence is given to you. How to check whether it is a Cauchy sequence or not, that we will discuss. Let us suppose an is a sequence defined as an is equal to sequence 1 by n. Let epsilon greater than 0 and n is greater than m. Now consider modulus of an minus am. What is an? Given sequence 1 by m. What is am? Mth term of the sequence 1 by m. Now what is the relation between n and m? Since n is greater than m, this implies 1 by n is less than 1 by m. This implies 1 by n minus 1 by m is less than 0. So you got this term 1 by n minus 1 by m. We know that if a is less than 0, then modulus of a is equal to minus a. Then this term, then modulus of an minus am value becomes 1 by m minus 1 by n. Can I write this value is less than 1 by m? Exactly, because 1 by n, see here, n is a positive integer. We know that because sequence is a function defined from natural number set to real number set. So n is a positive value, 1 by n is also positive value. From this quantity we are removing some positive quantity. So definitely this is less than 1 by m. This quantity is less than epsilon whenever m value is greater than 1 by epsilon. That is, for any epsilon greater than 0, there exists a positive integer m. What is that positive integer which is greater than 1 by epsilon, such that modulus of an minus am is less than epsilon for all n greater than or equal to m. See here, now it is satisfying the condition of a Cauchy sequence. Therefore, sequence 1 by n is a Cauchy sequence. Thus, for any epsilon greater than 0, if there exists a positive integer m satisfying this condition, then that sequence is called a Cauchy sequence. And this positive integer is also depends upon the value of the epsilon. Now we will take some particular values for epsilon. Here remember that for this sequence an is equal to 1 by n, the value of m is equal to 1 by epsilon. Means if I take epsilon is equal to 0.01, then what is our m? Our m is greater than 1 by 0.01, means our m value is greater than 100. Greater than 100 means m takes 101, 102, 103 and so on. So this modulus of an minus am is less than epsilon for all m n greater than or equal to 101 and so on. Now see here in this example, for any epsilon greater than 0, there exists m which is greater than 1 by epsilon, such that modulus of an minus am is less than epsilon for all n greater than or equal to m. See here, if I choose epsilon is equal to 0.01, then what is the m value? M is greater than 1 by 0.01, that is m is greater than 100. That is, what is, how to choose the value of n? n should be greater than m. What is m? M is greater than 100. So let us choose n is equal to some 103. Then what is m? M is a value which is greater than 100. Greater than 100 means, let us suppose m is equal to 101. Means what is this one? This becomes A103 minus A101 is less than epsilon. Similarly, you can choose different values for n and m. Let us suppose A200 minus A150. This value is also less than epsilon. What is epsilon? 0.01. Here also epsilon is equal to 0.01. Means if we choose the values like this, the difference between these values becomes less than epsilon. Means after some fixed point. What is that fixed point? After 100th term. After 100th term, remaining all terms are come close to each other. That's why this sequence AN is a Cauchy sequence. Now we will discuss one more example. Now we will see one more example. Let us suppose sequence AN is equal to n by n plus 1. Let epsilon greater than 0 and take n is greater than m. Then modulus of an minus am value. What it is? Modulus of n by n plus 1 minus m by m plus 1. This can be written as, see here, n by n plus 1 can be written as 1 minus 1 by n plus 1 minus 1 minus 1 by m plus 1. 1 gets cancels. Here this becomes positive. This is 1 by n plus 1 minus 1 by n plus 1. Now, what we assumed? N greater than m means 1 by n is less than 1. This implies n greater than m implies n plus 1 is greater than m plus 1. Then 1 by n plus 1 is less than 1 by m plus 1. So 1 by n plus 1 minus 1 by m plus 1 is less than 0. Means 1 by m plus 1 minus 1 by n plus 1 is greater than 0. So you can remove this modulus. So 1 by m plus 1 minus 1 by n plus 1, which is less than 1 by m plus 1, because we are removing a small positive quantity. That's why this value is less than 1 by m plus 1, which is also less than 1 by m. And this quantity is less than epsilon. This quantity is less than epsilon whenever m is greater than 1 by epsilon. So here, that is, for any epsilon greater than 0, there exists m. What is that? Greater than 1 by epsilon, such that modulus of an minus am is less than epsilon for all n greater than m. Therefore, an is equal to n by n plus 1 is a Cauchy sequence. So in this way we can check whether given sequence is a Cauchy sequence or not. Now we will take one more example. Let us suppose sequence an is equal to sequence minus 1 whole to the power of n. So let epsilon greater than 0 and n is greater than m. So let us choose n as a odd number and m as a even number. Then what is modulus of an minus am? That is modulus of minus 1 whole to the power of n minus minus 1 whole to the power of n. As n is an odd number, this is minus 1. As m is a even number, this is plus 1. So minus 1 minus of minus 1. So this is a modulus of minus 2. Finally, it is 2. But it cannot be less than epsilon. It cannot be less than epsilon, because see here. Let us suppose if I take epsilon is equal to 0.5, 2 is less than 0.5 is meaningless. That's why this is not less than 0. So if I take any value for epsilon which is less than 2, this is not possible. That's why here for any epsilon greater than 0, there does not exist m such that modulus of an minus am is less than epsilon. Here there does not exist m satisfying this condition. Therefore, this is not a Cauchy sequence. In this way, for given any sequence, we can verify whether it is a Cauchy sequence or not. This Cauchy sequence has so many applications in satellite designing, manufacturing, construction and etc. And in the next class, we will discuss, is there any relation between Cauchy sequence and convergent sequence, Cauchy sequence and bounded sequence? In the next class, we will discuss, is Cauchy sequences convergent, is Cauchy sequences bounded, or every convergent sequence is Cauchy sequence or not. We will discuss about these topics in the next class. Thank you all.